Hi gemologists! Welcome back to Hunt Country Jewelers Kids Gemology Detective video series. We are now in video number 2, and today we get to start discussing gemstones, and very specifically the visual properties of gemstones. But before we get started, we should probably define exactly what a gemstone is. So for our purposes, a gemstone has 3 traits: beauty, rarity, and durability. So it's got to be pretty, it's got to be not readily available, and it has to be able to last. Now, the first thing we see when we look at a gemstone, any gemstone, is color. So color is going to be the first visual property that we discuss today. At first glance, if you'll forgive the pun, color may seem like a very simple and not super helpful attribute of gemstones, but in fact, it is incredibly helpful. It's actually integral to gemstone identification and very specifically to gemstone value. Take a look at these 2 stones. These are not our mystery stones, but 2 good examples of how color can assist us in identification. This is a peridot, and this is an emerald. Now tell me, what color is each stone? Green, of course. But can you tell me which color green our peridot is? There are hundreds of variations on the color green. So how do we begin to differentiate which green our stones are? So let's take a look at basic color theory. We have 3 primary colors: red, blue, and yellow. When you mix these primary colors, you get 3 secondary colors: purple, green, and orange. Our stones here are green. So in the jewelry industry, we would say that green is their dominant color. But we also know that in real life, there are lots of variations on the color green. So we use what we call modifying colors to help describe the variations in hue for the color green. When a gemstone is a perfectly equal split between the 2 primary colors, in this case blue and yellow, it needs no modifier. It is simply green. But when there is a modifying color, on one end, yellow, and on the other, blue, we put the modifying color first because that stone's color is now edging away from perfect green towards the modifying color. If we go too far in either direction, it switches out of being green and becomes one of the primary colors. So in the instance of our peridot here, we have a yellowish green, modifying color first, dominant color second. So if both stones are always green, but peridot leans yellow to medium and emerald is always closer to a pure green, then when you see a stone that's clearly yellow-green, emerald can be ruled out, and we can leave peridot as a possibility. This is important because identifying gemstones is a process of elimination, and both of these stones, by definition, are always green, but not the same green. So we can eliminate possibilities based on a simple visual evaluation of a gemstone's color. Let's observe our first mystery gemstone. What color is it? Green. So let's get specific in our observations of color for mystery gemstone number 1. This is a pure green, no modifying color, yellow or blue, so we could simply call it green. But it's not just green. We can see it's clearly a lighter green. So the color of a gemstone isn't the end of our color observations. Now we must discuss tone and saturation. So first, tone, which is defined by the Gemological Institute of America as a scale from white or light down to black or dark. We can see a representation of this scale here on our Pantone cards, with the light on the outside of the circle and the dark on the inside of the circle. Now, the jewelry industry doesn't use Pantone cards, but they're an excellent visual reference for us here. Now, this stone is clearly lighter and matches with the colors more towards the outside of our scale, rather than the darker colors more towards the inside, where it doesn't match at all. So we would call this stone light in tone. Now, saturation, also defined by the Gemological Institute of America, describes a color's strength or intensity. We're looking for how vibrant and vivid the color is. This color is quite vibrant, quite vivid, and most importantly shows no signs of brown or gray, which is how we describe less saturated stones. Still looks pure green, even over here with the grays. So this is an intensely saturated stone, even though it is light in tone. So again, observing our first mystery gemstone, let's describe the color once more with all we've learned. We seem to have a simple green color that's light in tone, yet still a very bright and vibrant color, which I would call an intense saturation. Let's record this on our worksheets. Mystery stone number 1. Our color is green, no modifier. Our tone is light, and our saturation is intense. Switching to our second mystery gemstone, let's observe its color. The dominant color is blue, but definitely a greenish blue. And the tone is dark, quite dark. And if we compare it to some gray, our stone has no traces of gray or brown, so the saturation is intense. Mystery stone number 2. Our color is greenish, blue. Our tone is dark, and our saturation also intense. And now, when you hear a gemstone described as green, light in tone, but intense in saturation, you'll have a mental picture of what that green actually looks like. And that's important because specificity means we are all on the same page. This is important for mystery stone number 1. If we return to our reference cards, specifically, I'd like you to find one that is mineral corundum, variety ruby, and see what it says under color. Red. The dominant color for ruby is always red. If the dominant color is not red, it cannot be a ruby by definition. So we can eliminate that as a possibility for our green mystery stone number 1. And in the same vein, we can eliminate both emerald and ruby as possibilities for mystery stone number 2. Since emerald is always dominant color green and ruby is always dominant color red, and our mystery stone is dominant color blue, it cannot, by definition, be emerald or ruby. So with a simple observation of color, we are already beginning to eliminate possibilities for our two mystery gemstones. Next on our list of visual observations to make is transparency. Transparency is how much light comes through the stone. And there are 3 levels of transparency. There is opaque, in which no light travels through the stone. Translucent, in which some light travels through the stone. And transparent, in which a lot of light travels through the stone. Transparency, much like color, won't identify a gemstone by itself, but it's an important clue in our process of elimination. Take a look at these example stones. We have a lapis lazuli, a jade, specifically a nephrite, and a pink tourmaline. When we take that lapis lazuli and put it up to the light, it blocks all of that light. No light comes through the stone, so it is opaque. Now, the jade allows some light through, so we classify it as translucent. And the pink tourmaline allows lots of light through, and we call this transparent. So here is an example of the kind of elimination that we can do with the visual observation of transparency. Here's the lapis that we have already evaluated for transparency. It is opaque. Lapis is always opaque. Another commonly blue stone, sapphire, however, is opaque, translucent, or transparent. So this one right here could be lapis or it could be sapphire. But when we evaluate this one and see that it's very transparent, we can rule out lapis for this sample. We have not conclusively identified it as sapphire, but we have conclusively ruled out lapis lazuli. Now our 2 mystery gemstones. So let's take a look at our first mystery gemstone. And that has a lot of light coming through it. It's obviously clear. So we're going to classify this one as transparent. And our second mystery gemstone, again, that has a lot of light coming through it. This one is darker in tone, as we know from our color evaluation, but that is not what we are looking at. It appears to be darker, but we are looking at how clear the stone is. This one is very clear, so it is also transparent. Both of our mystery stones are transparent. Okay, last section, fluorescence. How many of you are familiar with black light bulbs? Those funny purple light bulbs at parties that make your t-shirts glow. Well, those are actually long wave ultraviolet lights emitting at a wavelength of about 385 nanometers, which is practically invisible to your eye. Did you know that some minerals also glow in the dark? When UV light is absorbed and the energy emitted is a visible light, we call that fluorescence. Some gemstones fluoresce, some don't. Now, we use lamps that use the long wave UV, but also a short wave UV, which is 254 nanometers. Fluorescence is a natural phenomenon, and some gemstones are more likely to fluoresce than others. But before we go too far down that road, let's take a look at what fluorescence actually looks like. This is a diamond ring. What is your hypothesis on its fluorescence? Will it glow under UV light, or will it not glow under UV light? But in order to really see the difference, we're going to need it to be just a little bit darker. If you guessed yes, you are correct. If you guessed no, you are correct. Some diamonds fluoresce and some do not. So in this ring, for example, we have the center stone here, which has very high fluorescence. It glows a bright neon blue. We have a side stone over here that has kind of a medium fluorescence. It glows, but not as bright as the center stone. And we have this side stone over here, which has no fluorescence at all and doesn't glow at all. Diamonds are not sorted by fluorescence during the manufacturing process, so you will often find a mix of levels of fluorescence in any given jewelry piece. So how does fluorescence help us in gem identification? Well, fluorescence does have its limitations in identification, but like all our other clues, it does help us with our process of elimination. So let's say we need to identify an unknown white stone that you have found. We put it under the black light and it glows bright blue. It's more than likely a diamond. That's the highest probability. Same if it glows a light blue. If it doesn't glow at all, well, we're going to have to do some additional testing. But what happens if it glows neon orange? Technically, diamonds can fluoresce in any color, but the neon orange is most closely associated with and often seen in a cubic zirconia. So we can generally eliminate diamond as a possibility if we have a neon orange under the black light. So here we have Mystery Stone A, and we're getting quite a bit of neon orange fluorescence. Gemstones, like diamonds, can fluoresce in many colors, although there are patterns we get used to seeing. This is a very interesting development for Mystery Stone number 1. Okay, gemologists, let's observe Mystery Stone number 2, which, believe it or not, is in there. And the reason we can't see it very well is because this stone is not glowing at all. It is what we call inert. I-N-E-R-T. You'll see that on your worksheets. And it means that there is no fluorescence. This stone has 0 fluorescence. Mystery Stone number 1, fluorescence? Yes. Mystery Stone number 2, fluorescence? No. So both of our mystery gemstones are transparent. And if we return to our reference materials, we will find that that doesn't really help us eliminate any additional possibilities. However, Mystery Stone number 1 fluoresces, so we can eliminate glass as a possibility for Mystery Stone number 1 because glass is inert and does not fluoresce. Mystery Stone number 2 doesn't fluoresce, so we do not get to eliminate any additional possibilities for Mystery Stone number 2 based on its fluorescence. All in all, we have, with 3 simple visual tests, eliminated 2 possibilities each for our mystery gemstones. Okay, gemologists, let's sum up what we've done today. We were able to eliminate some of the possibilities for our mystery gemstones. through our observations of their color and through their reactions under UV light or their fluorescence. Our other test, transparency, did not eliminate any possibilities, but that's okay because we did a lot of really good work today. We learned how to accurately describe gemstone color, tone, and saturation. We learned about the reaction under UV light or fluorescence, and we learned about how clear gemstones can be with transparency. That's an incredible amount of work, and you did a really good job. I'm very proud of you. And I can't wait to get you back here for video number 3, when we tackle the microscope and your loops at home to see what's going on the surface of the gemstone and also inside the gemstone. And we're also going to spend some time with 2 machines called a refractometer and a polariscope, in which we're going to start investigating how light travels through gemstones. It's going to be wonderfully exciting, and I can't wait to do it with you. We'll see you soon. Now this is important.
Very.
Super important. I don't remember how I started. Come here. Hi. So if both stones are always green, our first visual inspection. It's not at all what the script says. And there's a dog making all sorts of noise. And what those terminology pieces are?